sets and events and its ways to interact in data science. Hi, I am M. Asif Hussain from KnowHow Academy. What are we going to learn in this video? We are going to see what are sets and events, what are non-empty sets, and what are the different ways to interact with the sets. So when I'm talking about the word called sets and events, so these sets and events, we have learned this in our schooling, in our plus 11 and 12th standards, and even in the graduation as well. So there are multiple events that will be occurring, and there are multiple sets that we have, and we represent sets like this. So we might have all learned these things in our schooling. These are the basic things that we might have a basic idea on it. But so why these sets and events are again being discussed here when I'm talking something about data science? So these sets and events, these are really helpful to express or to tell how this numerical ways we can represent some numbers. Okay. So now this events and sets, when I'm talking about, let me explain it to you step by step way. So when I'm talking something about an event, so here what is event? In general, what is event? Some occasion, right? Some event, birthday event, or retirement event, or any occasion in a college, university, home, with friends, and so on. So what is event happening? So you are doing some, for example, a birthday event. You are doing some birthday party. Okay, you are inviting everyone. You are giving some possible outcomes that you have some birthday party. Am I right? So in the same way, so the set of favorable outcomes, we call it as an event. Let us consider in a very general way, in a set of favorable outcomes, we can consider as, we can call it as a event. What are the different set of favorable outcomes? We call it as a event. Now when I'm talking about an event, okay, out of event, let me take to you something about called even. So what are even numbers? In general, we define even numbers with 2, 4, 6, 8 divisible by 2 and so on. Am I right? So now these values of a set, they don't always have to be numerical. Okay, so these values of a set that we are representing, it doesn't require always to be numerical. Okay, so now if I would like to talk to you about sets, okay, sets, these are usually being represented in uppercase. Okay, so these sets, these are usually represented in uppercase. So for instance, if I take to you called even, okay, so it is not required to have the number alone, numerical alone. I can write like this also. But events or elements, if I would like to consider, okay, so these are represented in a lowercase. Okay, so this purely can call it as a numerical 8, something like this, 9, 10, something like this. Okay, so now here what's happening? Any set, it can be either empty, so or it can have some values in it. If the particular set is empty, okay, if the particular set is empty, we call it as a null set. We call it as a null is nothing but empty, or we even call it as a empty set. So now whichever are empty, we call it as a null set, or we call it as a empty set. But whichever are non-empty sets, it means that wherever we have some values in it. So wherever we have the non-empty sets, non-empty, it means that it has some values in it. So wherever we have these non-empty sets, these we are dividing it into two types. One is finite set, another one is infinite set. We are dividing it to two types. One is finite set, another one is infinite set, and these both are purely dependent on the number of elements that we have. These purely are dependent upon number of elements that we have. Okay, so always remember, we have two types of sets, which is finite sets, infinite sets. If we do not have any value, we call it as a null set or empty set. Okay, so now how should we represent this one? So for example, let us consider X as elements and A as set. Now So if you would like to relate this one, we use this symbol. No, it is looking like E, but it is not E. We usually call this as X in A. We call this as X in A. It means that X is an element of set A. X in A. So this it is called as in. Okay, X in A. X is an element of set A. Now, if you would like to tell that A contains X, so if you want to reciprocate it, so A, then we just reverse this E, in X like this. Okay, A contains X. It means that A in X. So now, if there is some empty set, if there is null set, so that how are you going to write it? Or it is not an element of, if it is X is not an element of set A. Okay, so how will you write it? X not in, you cancel it, not in element of A. X is not in A. Or if you want to write like this, A, it does not contain X, something like this. Okay, so this is how you talk, or you when you are in a oral, when you are talking and expressing this one, you cannot write X E A. No, X in the element of set A. X in A. A contains X, something like this. Now, okay, if I would like to show you the generalized statement with multiple elements, if we have, how are you going to represent it? So understand these representation of sets and events so that it will be easy for us to work on the mathematical calculations that we discuss it in our future videos. So whenever I would like to tell that for all the sets or for any set, then how should we represent this word called for all? For example, for in we have represented like this. So for all or for in, we write it in reverse A. We represent it as for all or for any So if I talk to you as an example, if I write like this, what does it mean? It means that for all X in A. So this is what we can write it. I mean, for all, for any, we will write with the reverse A. Now, okay, we have another symbol as well. We call it as colon. We all know what is a colon, right? Colon symbol. Okay, colon, 2 dots. Okay, this is colon. This is colon for me. Okay, so colon, we call it as a colon, but when we are talking in a mathematical way for sets and events, we call it as such that. Colon, it's nothing but such that. Okay, so why we use it? I mean, this colon, we use it to make the statements about specific group of elements. We use this such that as a symbol, or this colon, we use it to make the statements about specific elements within a set, inside a set. Okay, so if I write like this, so this is a symbol X in A such that X is even. Okay, so what is this one? For all X in A such that X is even. Okay, this is how we pronounce it. So when we are pronouncing it, it's looking very big, but we represent it in the symbols and as part of letters. It is something looking like this. Okay, as simple as such. So we also have some other thing called as a subset. You might have heard this one. We have something called as subset. So this subset is a set that is fully contained in another set. A set inside another set. Subset. Okay. So how we call as a subqueries. A query inside another query. We call it a subquery in SQL. In the same way, we use a set that is fully into the another set. Okay. So how do we represent this one? A is a subset of B. Okay, A is a subset of B. So every set, it at least contains 2 subsets. Okay, so if we consider A is subset of B, and for example, if there is null, no subset, no set in it, so null is a subset of A. If it is null, so null can be represented like this. This is subset. Now let us understand what are the different ways to interact with it. So when I am talking about a set or a subset, let me consider with a small example. Okay, we have something called as A and we have something called as B. Okay, So these two are not combining. So A is different, B is different. Am I right? These two are not intersecting. But what happens if I write like this? A is intersecting with B. A is intersecting with B. This is called intersect. Am I right? Two events can occur at the same time. When I am talking about this intersect, it means that two events occurring at the same time. Now, what happens if I write like this? Set A is getting overlapped with set B. Set A is getting overlapped with set B. Overlapping. This is called as overlapping. What is meant by overlapping? An event can occur only if the other one does well. Okay? Only if the other one does well. For example, if I want to pick A, if I want to pick B, okay, first I have to get A, then I will get B, right? So, but intersect it is not like that, okay? So, what all we have in set A and set B, and the common between the both, we get this as an output. Two events occurring at the same time, all right? So, one it is the open one which is not getting interacted. The second one is intersect, and the third one is overlapping. So if I would like to give a simple one-line conclusion for what we have discussed in this sets and different ways to interact it and non-empty sets, so it is nothing but if an outcome is not a part of a set, if an outcome that we are expecting it is not a part of a set, it cannot be part of any of its subset. Okay, if it is not a part of a set, it cannot be part of its subset also. All right. So whenever we are talking about the sets and events or the different ways to interact this one, we usually hear this word called subset, and we usually hear this word called intersect, okay, where we talk about this different variations or matrices that we have in the mathematical calculations that we'll be discussing it in the future videos. So thank you for choosing KnowHow Academy as your source for IT knowledge. We are always here to help you to navigate the tech world. If you have any questions, do not hesitate to reach out. It's been a pleasure sharing this information with you. Stay curious and keep learning.